Again, this is the very last week already. We will do a little bit review on what we have learned so far from last 7 weeks. So for the very beginning, when we did uh, the pre-work, so what did we do? The tip calculator, right? And then last one is just a very basic one, just do a view controller, the first one, and then you go to the setting page and you use the NS user default to save the tip percentage, going back to the first one. And then for the very first week, we learn about the table view, and then some very basic network functions to get some data from the API, the movie database API. Second week, what did we learn on second week? Forget already. Yep. Right. So that one is auto layout and the delegate. Right. So in second week, learning auto layout and delegate. So don't ask me what is the delegate now. Okay. some some previous class we had some student after the end they asked me what the delegate. All right. They finished their project, but then at the end they still asking what is the delegate. Okay. And then week three. The assignment is Twitter, right? So we keep talking about the networking. So we use the API from Twitter, and then also learn about the what do we learn? With three, the award, right? Right. How to use the award to connect to the Twitter API. And with 4 on animation, with 5 on a custom view and custom transition, where we learn the zip and nip. Right. So that's one also help a lot for the team if you're working on like a big project, and then you need to split the storyboard into multiple users or multiple team member, and you can it's an advantage to use zip and nip. And then with 6, what is with 6? I also forgot. Nothing with 5. So with 6 we learn some framework from the device, like the device we have. We learn about the map, the contact, the video, camera, and audio, something like that, right? And with 7 just talk about the persistent. We do some introduction about RAM, NS user default, and the file system. Okay, and then this is the very last one with 8. So we are going to talk about the UI kit dynamic. So what is this? The final one. Congratulations, you still here. The very final one. So you see, we start 25. We are now 15. So 10 people left. Okay, so let's talk about the UI kit dynamic. So what this? Actually, this one is the framework. So again, another framework that are modeling the real world physics on the UI view object. So we have been all the time we have been using the UI view, right? So all the thing you have been using right now is like the button, the image view, the view, the label view, the table view, whatever. That's all the things the subclass of the UI view, right? And then UI kit dynamic. So here we use the UI kit dynamic to apply the physics onto the UI view. So when we're talking about physics, what do you think about physics? Yes, gravity. And then what? Velocity, right? And then the collision, the two things hitting together, right? Something like that. And then we will use those the UI kit dynamic function to apply the physics on the UI view object. And this is the same physics engine that's using in the Sprite kit. And if anyone know about Sprite kit, that's why want to use to build a game, 2D game, also from the Xcode. So it's exactly the same the physics engine, but the only difference is that this one is built to use with the UI view. So before we do some visiting on the UI view object, so we have a thing called the dynamic animator. So this one is the core of the UI kit dynamic. So this will be handle everything inside, like excuse me, like inside the world. So you create an app, so that app will be a world, and then the UI dynamic animator will be the one that controls that whole world. It can set the rule for that world. So you can, for example, you can set the behavior. So later we will learn what is the behavior, and then how the what is the item of inside of the behavior. So some of the behavior as we talked earlier. So we have gravity, collision detection. So something hit together, we had push and snap and attachment, and this is repeat, this is collision again. Okay, so that some of the behavior we will talk about in the animator. Okay. So again, this is just the um, illustration for the UI dynamic animator. So again, we have the UI dynamic animator. This one, the biggest one, and inside this one, it can have multiple behavior, right? So in this world, you can have multiple behavior. For example, the gravity and the collision and attachment, those kind of behavior, and it depends on the behavior. It can have multiple items inside that behavior, or just one single. Right. For example, if you had the gravity just itself, it's only one item itself. It only had the gravity. But when you're talking about the collision, and it should have at least two items, right? Collision. So it should have at least two things as one can hit together. Or if you only have one thing and you have, for example, you create your app and then you can create the battery. Your apps, your phone screen can be the battery, and we can also do the collision between whatever the item inside that one and the battery. So the battery of the screen can be also another item. So later we talk about that one. That's why you see here within the animator we can have multiple behavior, and within the behavior we can have either like single item or multiple item. In this case we have single item. In this case we have multiple items. Right. Now we're talking about the dynamic item. So go back to this one. So we had the animator, behavior, and inside the behavior will be the item. So item, no. Okay, this is a protocol that define. So when we're talking about the item, so we normally should have something like the battery of the item, and we define the center of the item, and the last thing is the transform. So remember the transform, we have something called CG or file transform before when we do the animation, right? Remember in Quick 4 we have something like animation when we want to transform that one to be bigger, like 2x bigger, or like few s smaller or something, or you want to rotate the item. So that's one we call the transform for the item. Dynamic item is that the protocol that defines those three things, and center the battery, and then the transform of the item. Okay. So we had three things here, and then we can insert the item into the behavior. Okay, so later when we do the code, and then we can demo that one. And during you doing some like physics change, for example, you are making something hit together, and that's one it can be broken or something. Like you changing the center of the item, or you changing the transform of the item. So like you made it like squeeze the thing, and it becomes smaller or something. Then after you finish the animation, you need to call this one. So update the item using centers, the current state. So like after you do some behavior with those item, it can change the center. For example, you hit something, it move, or you push something, it move the item to another place. You need to call this one, the UI dynamic animator, and then update item using the current state. Okay, so we're talking about a few behavior here. So the first one, the gravity behavior. So gravity, so we have two property for the gravity behavior. So the first one will be angle, and the second one will be magnitude. So you read the note here. If you set magnitude is 1, is so that one will be 1,000 point per second square. We try that one one by one later. You see. Here is the attachment behavior. Attachment, so when you say attachment, you should have something attached to something, right? Attachment. It at least had two items, and this one item is attached to something, so another item, or you can set that attached to another. We call the anchor point. So you have few API here. So like this one, you attach item to the anchor point, or you attach item to another item. Collation, again, collation also we should have at least two items to make it collide together, right? So here we can have that those items. When we set the collation behavior, it can either set those items to collide together, or those items to collide to the boundary. As I said earlier, for example, you create the boundary of your UI view to be one of the items. Like that's one the boundary of the wall. So everything, if you hit to the wall, then it should detect the collation event. Right? Snap is what? So we have snap and push. So what is the difference between snap and push? Okay, so before we can differentiate between those, let me open this one. It's easier to have something to explain. What is? Is it running? It's not running. Okay. Look like hang already. And with Xcode. Okay, we do the demo later. So we have the snap, for example, we have some item here. When we snap on some point here, that the item move to that point. It's really easier if I can show the demo, but let me restart the Xcode and we try that one later. And push means what? Push, for example, we have some item here. So push, we will have two mode for push. So as you see here, we had continuous and instantaneous. Some continuous mean what? So you keep apply a fork onto the item, like keep pushing the fork, keep pushing the item like this one. If we use the continuous mode, right? And if it's instantaneous, meaning what? We just try to push one fork and then this item will move and later it will be stopped, right? We don't keep apply the fork onto the item, just one push and then whatever how fast can go away and it just go, and then later at some moment it will stop, right? So for the pushing, we also have the direction of the push, the angle of the push, and then the magnitude of the push. And one note here, if we use the instantaneous, so either you just apply the fork once, so you just hit the item once and the item move, but the behavior just sitting there and using up the memory. So there one note here on the, where was it? Okay, here. So on the boost behavior, we are there one node here that to avoid memory leaking. So after we do the we set the boost behavior and then we apply that that's one on the item, then we should remove the behavior. If we don't remove it, like if you just boost only one time, boost the item one time, but you don't remove here, so this behavior is still sitting there, right? And it just use up the memory, so that's why it can we record the memory leaking, so that's why in this case if we use the instantaneous boost behavior, should manually remove the behavior at the code like here. So actually this is the slide from Stanford, so also online courses, so I take the slide from there. Let's go back. Okay, some of the item, so this is the behavior for the item. So we have some other behavior here. So for example, if we set the property for the item, if you should, and you read here that the name is infer the thing, so it's allow the rotation. You want the item to be rotate, or you want to create a friction mean like how to say massage. It's been easier. Okay, so you want to apply the friction. It's in the ideal world is no friction, but if you want to create that look like the real world, so you can also add the friction into the item. Or the elasticity what I remember earlier we had some like damping effect, right? For example, where you create the animation with a damping effect, it's like bouncing, and the elasticity also something similar to that. When you drop something to the ground, it's like it will deform the item, or is bouncing back the item. So if you don't set the elasticity, it's like a very heavy item drop on the ground, and that's it. That it just hit on the ground, it's just sitting there. Or if you set the elasticity like the bone, it drop to the ground, it can bouncing back. Right. That's the elasticity. And okay, so and here when we talk about the animator, so we also had the delegate. The delegate for what? To make or like observe the thing happen for you. For example, here we have the animator is like it did. We have two things here: the dig ball and then the will resume. So when you detect the item is start to happen, or the behavior is start to happen. For example, you want to detect if some item start to collide with something else, then you can use you can check if the behavior is only is when it start to hit what you want to do, or during it hitting that another item you want to do, or you can pause and then also resume the behavior. We try those in the leave demo later. Okay, so some example here. So what is the difference between those three pictures? Can you tell the difference? Phùng, what are you doing? What did so if you look at it, three picture, there are two items on each picture, right? A red paw here and also a square. So like what will be the difference? Yeah. Mm-hmm. So like we didn't apply any behavior on those two things, right? We just let there we just leave place the thing there, and it just sitting there, right? And the second one, mm-hmm. So if we have like the collision between the square and then the red bar here, right? And it hit to the red bar and it drop. And then the last one, so the bar it attached to the wall one of the wall, and then uh, this square fall down, and this is too light, this one too heavy, and then it just rotate. Right? The square rotate, it will be continue to drop down. So if anyone using, so actually a lot of games on App Store, they use the physics engine. I don't know if anyone used to play the game before. So like the puzzle game, you using some physics law to try to show some of the puzzles. It's those applied the same thing with a UI dynamic here. Okay, so yeah, this is some of the explanation for the one you just saw before. So we had a reference view. So normally the reference view will be the whole UI view, and then we have within that one we had a UI dynamic animator, and then we have the gravity, and then the collision behavior. Right? So the gravity will be applied on the square, and then the collision behavior also applied on the square, and then when the square had a gravity, it drop on the red part, and then it had a collision with the red part, and then it depends on the weight or the red bar. We can red bar, is it attached to the wall or not, and we have some behavior like the three picture here. Okay, so we will try some coding. So how do we do? We will learn by converting. So what do we mean converting? Go back to, let me copy this one. Yes. So this is the sample code from Apple. Right? They have the UI Kit dynamic catalog. So they implement on the behavior of the UI Kit dynamic, and then but actually unfortunately this one it was written in Objective-C. We can download the sample code here, and then when you download have some project like this one, and when you open this one is in Objective-C, and then we will learn how to use the behavior, and also how to convert the Objective-C to Swift. Anyone familiar with Objective-C here? No. No one used to work with them except this guy. Okay, I need to open again. Okay, so what do we see here? I open the project and we see bunch of HMM file. So this is Objective-C, right? So if you see the H file, what is the S file? The .h, yeah, header, and then in this one it just only contain the interface. So you see here a lot of H file is only had the interface. And then what is the M file? The M file is actually the implementation for the function. So the H file is just like it contains the function name, I think, just but all the code will be in the M file. So we will do convert the file. We will not do 100%. Just I show you a few how to do the conversion between Objective-C and also Swift. It's also good for you later if you you searching for something on the internet, on the Stack Overflow, and then those questions were very old before, and then people just reply on the Objective-C, and then you also can look at that, and then you know how to convert that one into Swift, right? Okay, so take a look on this one. We have the main storyboard here. Okay, and in this one we have the navigation controller. Zoom is smaller. I see. Okay, so we have the navigation controller here. This is what the static table view, right? The static table view just drag in the every row here will be a static cell. You don't need to drag in the prototype cell. Just static cell, and you type in the value of that cell, and then each cell will have the segue to every single view controller here. So for example, the first one, you go to the gravity one, and then we have the action collision, snap, and then collision boost, right? Okay, so let me run this one, and I don't know if we can run this one. Try again. Wow. Wait a moment. So as Objective-C, you look at this one, it's like the same with Swift, right? So only thing that it had two files instead of one file in Swift. In Swift, you only have one .swift file. You don't need to split this one into the S and the M file. And then if you look at each view controller here, you see it's also the class will be the ABL gravity view controller, ABL gravity view controller. This one. So we will try to convert one by one into Swift. Okay. But before we do that one, let's wait. Okay, while waiting, let me create a new group here. I go in Swift, and I will put all the code for all the Swift code inside that group to make it easier. So the first one, we had the gravity view controller. So for example, we try to convert this one, but the easiest one and the very first one. Why waiting for that one? I don't know why it's so long, so slow. So this one will be gravity view controller. So similar to what you did before, right? Just create a class, create a subclass of the UI view controller. I call it gravity view controller, right? And I put that one under group Swift. We create that one. Okay, so look at this one. So at the very first time you create some Swift file inside a Objective-C project. So it will ask you to create which side. It will ask you to create the bridging header. So why the bridging header? Yes, it's an H file, but then if in your code you have like the merge between Objective-C and then Swift, so you need to have something that to let your project know, hey, you can also use the Swift file or the Objective-C file. So when you create the bridging header, so this is where, so you just select create. Okay, so it have here dynamic. It actually the empty file. So but if you see here, you need file to import your target public header that you would like to export to Swift. Right. So if anything from the Objective-C, but you want that one to be exposed to the Swift, you need to put that one here. So it's just the header, so you can import or whatever, do the import in this file, and then later in the Swift you can see this, you can see the thing from this one. So for now we don't know if we are going to use anything. It just create a empty file there, so just leave it there. I don't care. So we go to here, the gravity view controller. You go to main storyboard. Okay, here the gravity thing one. So you click on this one and we change the class to the gravity view controller. I remove the ABL, whatever the ABL, I remove that one. So now the owner of this view controller will be the file I just created, right? The gravity view controller.swift. Right. Okay, we do the code layer. It's already finished this one. Let's try this one first. So on the gravity, when you click on gravity, see, it's too fast. Just click on the gravity and you see, you observe that the square, it has the gravity and it just drop down. Right. Let's go back. The second one is collision and gravity. So why it could be different? So you see here on the ground you have some. Look at the ground here. There's some like an image here to indicate that this is actually we had the ground. It's not like before it just drop forever. But in this case we had the ground, and when it hit the ground, you have some bounding effect, right? it hit the ground, it's like bend back a little bit and then we stop. Right, so that's the difference between the gravity and then the gravity with collision. So in this case, we collide that one with the boundary of the UI view. So we try to convert this one for the gravity. Let's go back to the gravity one, and then I open this one. So what do we have here? Under gravity, we just have one item, right? And this item is actually the outlet is square 1. Right, the outlet of this one is square 1. Okay, and then I need to create that outlet inside the script file I just created, right? So let me create that one. So square 1 outlet. Okay. Whoop. And then now I need to open the at the bottom. I want to open 2 files at the same time, then one script file and then one Objective-C file, and I can copy from. Okay, so here I need to change the manual, and I want to open the gravity view controller.m, the implementation file, not the header file. So okay, so we will convert the file at the bottom to the file at the top. Right, what do we have here? So you already have the square, right? The outlet here, square 1, and we have the animator. So when you see something like this, right, it's actually what you declare a new variable called animator and the type the UI dynamic animator, right? So you can go up here and say var animator, go to what that UI dynamic animator, right? And then below, what do we have? View did appear. It's only view did appear. The rest we can remove, so I don't need so the thing just remove, and we need the view did appear. So one line by line. So we had the super view did appear, view disappear, and then animator choose. Yeah, so we have the animator here. So we instantiate the animator, right? So we have animator dot what? You see something here, init with reference view, right? And you do the same thing, init what? Too small again. Presentation. Now too big I cannot see. Where was it? So we have animator dot where was it? What is it? Init with reference view dot init and then hey, what that UI dynamic animator UI init. Okay, so we have something like this one, init. And earlier in the Objective-C we had the width, but now machine script 3 and then I remove all the width. So if you see something width like this one, you can, you know, that's in the script now it's no more width. So you just init here, and I also put the reference view inside the parentheses. So we have here the init init with the reference view. So what is the view here? And cell.view, right? So just put here cell.view. Okay, the next thing you want, the gravity behavior. So we create a new gravity behavior, right? So let gravity behavior, go to UI gravity behavior. And what we also have something called init with the item. So here, how many items do we have? See here items when we have a list of the item. so you can attach a list of item into the this gravity behavior. But in this case, we just have only one thing, right? It would be what cell dot square one. Okay, so we just have one item, and the next thing is what we up to this line, right? We add the behavior into this animator. Right, so animator dot add behavior. So you see add behavior, and then we add the gravity behavior here. So that's it. Right. To make sure we running in Swift, try to lock something here in Swift. Right. Okay, and then try to run. Okay, we have the gravity here. So see, it say running Swift, meaning we successfully create the successfully convert the Objective-C file into the Swift file, right? And then if I now I want, I can delete this one. I don't need it anymore, right? Only we already set the owner for the gravity view controller to the Swift file, so actually I don't need this one anymore. Then I can delete this one. I can move to trash. Okay, that's one. Okay, let's create another one. The next one, collision gravity view controller. Okay, so same thing. I create within the group Swift collision gravity view controller. Okay, so this is the second time you add the Swift file into the Objective-C, so it will not ask you to create a bridge file anymore. So same thing, we going back to the main storyboard. That one will be what? Where is it? Collision gravity, right? And this one, I say collision gravity view controller. So this is the Swift file, right? And what do we have here? Let's see the M file, and we have the square one. Same thing as earlier, so we have the square one and we had the animator. So okay, go back to this one, collision, similar to here. I just copy the thing from here. I need to go back to the main storyboard, and where is it? Collision gravity. So this one, I create the outlet. Is it? Yeah. Okay. Double check to see if I didn't create the double thing. Okay. So I create the square here and then the animator here. Okay, that's good. So let's do the conversion. The file here would be collision gravity view controller. I again remove the other thing. I don't need it. Okay, so what do we do now? We had the animator here, we had the square one here. In view did load, we have the, so we do some initial setting for the square. So just set the color for the square. So we have square one dot image equal to square one dot image. Sorry, image dot what that image with render. What that? So we have here the image with render mode. Image with render mode. So we have the rendering mode here. Hey, no. be the own way template. Okay, and then square one dot tint color, UI color dot dark gray. Okay, so we done with the view did load, right? And in view did appear, same thing. View did appear, super dot view did appear true. Again, we set the animator so it the same with what we did before, right? UI dynamic animator dot init with reference view, and then the same here, cell dot view, and then we set the gravity view UI gravity behavior dot init. So how many items do we have now? Still one. So what do we have here is the cell dot square, and we add behavior gravity behavior. Okay, so this is the new thing, the collision behavior. So let's collision behavior equal to UI collision dot init. So same thing here, right? Init with item. So you have here and item again. The cell dot square, and then the collision behavior dot translate the reference bound into boundaries equal to true. So in Objective-C it will be yes and no, but in Swift it's like no more yes and no. It will be true and false, right? What does it mean here? In this slide we will translate the cell dot view, meaning the boundary of your whole view, into the boundary. So later we will use this one because we want to detect the collision between the item with the boundary. So you use this one, translate the reference bounds into the boundary. You can read the note here. So you will change the cell dot view boundary. Okay, and then we set the delegate. Right, so collision behavior dot delegate go to cell, and you know for sure after this one Xcode will complain, right? And you need to do some inherit from some other class, whatever the collision delegate, right? We do this one layer. We animator dot add behavior, and then we add the collision behavior. Okay, so now so you don't need to set this one. Okay, so it for sure will complain, right? You need something called collision delegate. What is that type? So UI collision behavior delegate. Okay, UI collision behavior delegate. Okay, and then which one is the required one? You go to there, optional. So no, the optional, but the thing is, what do you want to use? So let me see. It adding to begin contact for item. So meaning it detect as soon as the item start to touch another item, right? So we have the begin contact for item, and then we have the end contact. After it start, as soon as it start to contact, and then the very last moment when it totally contact the item and stop the animation. So we implement two things. Okay, so going down here, so we have begin now. What begin? Begin contact. Okay, so we have begin contact for item. We had two. Which one we use? I get this one. Begin contact for item with boundary. Is it correct? Begin contact for item with boundary identifier. add point. Okay, that's the correct one. So here we just want to set the thin color for the item. So item dot thin color. Item as the UI view. So let item UI view item dot thin color. No. How do I set this one being contact item UI dynamic item? Set thin color. Lighten the color when the view is in contact with the boundary. So we can contact for item. We have the item here. So why can't I set the thin color? How to set this one? How to set this one? Item dot color, no color. What did I do before? Got this one into how to set the lights, the thin color. Set the thin color. Sure, I'm done with item. No, that cannot set the thin color. Thin color is not showing up. I don't know. Yeah, but to create cut this one into the UI view and then it's set thin color. I don't know. In Swift it change to something. Yeah, UI view doesn't have the thin color. Should be the UI image view it will have. How will we set this one? Let's wait for that one. Going back layer. So we had the edit collation, edit contact for item. And then this one also says set the thin color. I need to check what I did before. How did I convert this one before? Collation.swift. Or I didn't use the item, I just directly use the square. But in this case we know that the square, the item not going to hit the boundary, so I do the cheating there. I don't know how to convert this line into the Swift, but it doesn't work that way. So let's do some cheating. Thin color is UI color. No. Dot light gray. Is it dark gray color and then light gray color? Okay. Same thing here. We had a dark gray. Anything else? Let's try to run. Okay, so the collation gravity. So you see, when it starts to hit the item, you see it slightly change the color of the square, right? It changes some colors, it's like easier to see. For example, I say red, and this one is become blue. So as soon as start to hit the boundary, it become red, and then after it release from the item, it become blue, and then after very end, it totally hit the item, it become red again. So that's the thing. So you see here, red and then blue, red. See, one more time. See, it become when it start to hit, it change. It start to hit, it will be change the color to red, but when it bounces back, going up, no more contact with the boundary, right? It's become the blue, and then at the very end it hit the ground again, so it becomes red again. So that's the thing. So what I just show you is to how to do the conversion for. So again, now I can do the delete for this one. Right? We no longer use those. Right. So that I try to show you that the two basic one how to do the conversion between the Swift and the Objective-C into Swift. And later, if you want to try, you can download the sample code and practice to do the conversion for the rest of the thing. I will not do another example. So now here comes the fun thing, the Flappy Bird, right? So let me try to open this one. Where were the Flappy Bird go? Flappy Bird accent. Okay. Flappy. Oh, I didn't convert it before. Hopefully it works. Don't run. Okay, so this is the one. So we will spend the second half of the class to build this one. You try to apply whatever we have learned. Here you look at the code here. We see we had the gravity, we had the boost. So what happened when we try to tap on the screen? What we tap on? So you still remember the Flappy Bird, right? Actually, the bird is not moving the S direction. It's just moving the Y direction. It's just moving up and down, and the thing moving in the pies. So the pie is the one that moving. So you will try to create the pie and then make it moving, and then every time you tap on the screen, you create the push. So it will push the bird up, and then you add the collision, so you will detect if the bird is hitting one of the pie. So this is the code we already implemented, and of course you see just 100 line of code. You can create a Flappy Bird. Let me try to run that one. Here, right? So we have don't too big. Here the screen. There we share to you the access to you for this one, so you don't need to create the image on your own. Just start coding from there. Let's try to run this one. See. So it's not optimized, and so not a great UI or create the one to save the high score or whatever, but we just create a very basic function to make the Flappy Bird game. And you see, I click the play here, the bird will start to fall down. So we had the gravity, and every time we tap like this one, like it's gone. So we didn't write the code for like to detect that hey, the bird is only hit the pie and then it should die, it should stop the game, right? See here, so we also create random. Every time we create random height for the pie. See here is different height for the pie, and then we will moving the pie on the S direction. Hold on. Okay. See, actually the pie the one moving and the bird only moving in S direction. So every time you tap the screen, so you need to add the gesture, the tap gesture to detect that hey you are tapping on the screen, and every time you tap you will apply the push behavior onto the bird, right? To push it, it's going up. That's it. Just make the push the bird going up, and then you making the power moving from the S direction, and then you do the detection between the bird and then the palm, right? Easy. Okay. So I will share the instruction how to build this one, and then you can follow that one. So time to build something fun now.